I hope all of you are doing good. Let's start today's chapter, Ratio and Proportion. Introduction. In this chapter, we shall introduce the idea of ratio and proportion. We shall also give the idea of unitary method and apply it in solving some simple daily life problems. Okay, ratio. In our daily life, we are often required to compare quantities in terms of their magnitude or measurements. Suppose we need to compare the weight of two students, Amit and Ajay, weighing 35 kg and 30 respectively. We can do this in two different ways. Number one, the difference of their weight is 5 kg, 35 minus 30. So we can say that Amit is heavier than Ajay by 5 kg. This method is known as comparison by difference. Number two, the same case we can write as weight of Amit upon weight of Ajay, that is 35 upon my 30. In other words, weight of Amit is 35 by 30 times the weight of Ajay. This is known as comparison by division. Okay. When we compare two quantities of the same kind by division, we say that we have formed a ratio of two quantities. Usually, we see this symbol. Okay. We see this symbol to express a ratio. So, we can say that ratio of weight of Amit to that of Ajay is this 35 ratio 30, or this is read as 35 is 2. Okay, this is 2. 35 is to 30. In general, we can define ratio as the ratio of two quantities in the same units is a form of a fraction that one quantity is on the other. Okay. In figure, as you can see, in figure 1, we can compare like this, that is 35 is to 30. In figure 7.2, this one, we cannot compare as there are different units, 6,000 grams and 70 kilogram. Okay. And in figure 7.3, we cannot compare as there are different kinds, that is 4 mangoes and 20 rupees. This for any non-zero numbers A and B. A is to B is a ratio written as A is to B. Okay, the term A, this is known as antecedent, and this term is consequent, which you already know because you have also studied about the same in the previous class also, right? Thus, a ratio can be expressed as a fraction. In the case of fractions, they do not change when their numerators and denominators are multiplied or divided by the same non-zero number. Hence, a ratio doesn't change if its first and second term are multiplied or divided by the same non-zero number. Thus, 35 is to 30 is equals to 70 is to 60 is equals to 105 is to 90, etc. So, when the two terms of a ratio have no common factor other than 1, we say that the ratio is in the simplest form. Okay. Another fact we need to bear in mind is that the comparison of two quantities is meaningful only when they are of the same kind and measured in the same unit. Thus, it is meaningless to compare animals and human beings or weight in gram and kilogram. We can compare weights only if they are measured in the same units. Let's do the example 1. We have to find the ratio of 50 to 100. So, 50 upon 100. 0, 0 goes, 5 ones are 5, 5 twos are 10. So, ratio is 1 is to 2. Now, we have to compare 60 paise to rupees 6. Okay, this is paise, this is rupees. So, first we will convert into the same unit, only then we will find the ratio. Okay, so we will write 6 as 600 paise because 1 rupee is equals to 100 paise and 6 rupees is equals to 600 paise. Now, find out the ratio. 60 upon 600. 0, 0 goes, 6 ones are 6, 6 ones are 6 and 0. So, 1 by 10, that is 1 is to 10. Okay, this is the ratio. Next, comparison of ratios. Consider a situation when we want to compare two given ratios. Then we need to express them in the form of fractions in the simplest form and then make their denominators equal and compare the numerators. Example, we have to compare the ratio 4 is to 3 and 4 is to 5. So, what will we do? First, we will write them in ratio 4 by 3 and 4 by 5. Okay. After that, what will we do? we will make the denominator equal by taking the LCM. So LCM of 3 and 5 is what? 15. Now make the denominator equal. 5, 5. 20 by 15 and 4 by 5. 12 by 50. Okay. So which one is greater? Obviously 20 by 15 is greater than 12 by 15. Right. 20 by 15 means 4 by 3. That is 4:3. 4:3 is greater than 4:5. Okay. Exercise 7.1. Number 1. Express the following in the language of ratio. In a school, the number of boys is 2,250 and number of girls is 2,750. So let's find out the ratio. Boys upon girls. Okay. Number of boys 2,250, girls 2,750. 0, 0 goes. Now 5 4s are 20, 5 5s are 25. 5 5s are 25, 5 5s are 25. Okay, now 5 9s are 45, 5 1s are 5, 5 1s are 5. 9 by 11, that is 9:11. Okay. Proportion. Let us consider an example. If a liter of milk cost rupees 50, 25 liters of milk will cost rupees 375 and 40 liters of milk will cost rupees 600. Okay. Now, the ratio of the two quantities of milk is 25 liters is to 40 liters. Okay. And 5:8 is the simplest form of 25:40. Again, the ratio of cost of milk is rupees 375 is to rupees 600, and then you will get again this ratio, which is 5:8. So here we observe that 5:8 is equals to 5:8. Thus in this example we observe that the ratio of the first two numbers is equal to the ratio of the third and fourth numbers. Such an equality of two ratios is called proportion, and we say that four numbers are in proportion. So what is the definition? Four numbers A, B, C, D are said to be in proportion if A is to B is equals to C is to D. Okay, and we write it as A is to B such that C is to D. Okay, so here A is called the first term, B is called the second term, C is called the third term, and D is the fourth term of the proportion. The first and fourth terms means this term and this term, these are known as the extremes. Okay, first and the last term, that is fourth term, and the second and third, B and C, these terms are known as means. Okay, so it is verified that in a proportion we have product of means is equals to product of extremes. So thus numbers A, B, C and D are in proportion if only if A into D is equals to B into C, right? Let's do the example 1. Are 25, 75, 70 and 210 in proportion? Okay. This is the first term, this is the last term. So first we will write product of extremes. Okay. Product of extreme is what? 25 into 210, right? 25 ones are 25, 25 twos are 50 plus 2, 52. Now, product of means middle terms, that is 75 into 70. Okay. So both the products are equal, same. Thus products of means is equals to product of extremes. That means these numbers are in proportion, right? Three numbers in proportion. Okay, three numbers A, B and C are said to be in continuous proportion if A, B, then B, C are in proportion. Thus if A, B, C are in continued proportion, we have A is to B such that B is to C. That is AC is equals to B square. B square how? Because product of means is B into B is equals to B square. Or you can also say B square is equals to AC. right? So here B is called the mean proportional between A and C, right? B is mean proportion. Let's do example. Find the mean proportion between 64 and 81. So we can write it as 64. We don't know what the mean proportion is, so we will let any variable like x, y, z. So let x be the mean proportion. So x is to 81. Now, product of extremes is equals to product of means. 64 into 81 is equals to x square. Okay. So x square is equals to 64 is square of 8, 81 is square of 9. Okay. Square x is equals to 8 into 9. That is x is equals to 72. Right. Exercise 7.2. Which of the following statements are true? Okay. 8 is to 12 is equals to 10 is to 15. Right. Let's find this out. 8 is to 12 is such that 10 is to 15. So first multiply the extremes. Product of extreme is 8 into 15, that is 120. Then product of means 12 into 10, that is 120. So both are equal, that means this statement is true. Now, learning outcomes. When we compare two quantities of the same kind with respect to magnitudes by division, we say that we have formed a ratio of the two quantities. Number 2, the ratio of two numbers is usually expressed in their lowest terms. 3, ratio has no unit in itself. 4, the equality of two ratios is called a proportion. If A is to B is equal to C is to D, then we write A is to B such that C is to D. Okay. 5, if A, B, C, D are in proportion, we call A and D as extremes and B and C as means or middle term. Number 6, 4 terms are said to be in proportion if product of extremes is equals to product of means. Thus, A, B, C, D are in proportion. That is, AD is equals to BC. 7, from the terms of a proportion, we can make 3 more proportions. And 8, if A, B and C are 3 numbers such that A is to B is equals to B is to C, then the numbers A, B and C are said to be in continuate proportion or simply in proportion. Okay, students, I hope you have understood this chapter and you will do the remaining questions of the exercise.